Lastly, let's look at problem 5. In problem 5, oops, let's add a little bit more space here. Okay, in problem 5 we have 3z plus 2 to the 5/3 minus 3z plus 2 to the 2/3. Now what we want to do is we should notice these have the same base of 3z plus 2. So we can factor out a 3z plus 2, but the question is, what exponent do we raise this to? I want to take a moment, look at a related problem. If you had x to the 5th minus x squared, we know we can factor out an x because we have the common base, and that we can in fact factor out an x squared, since square is our smallest exponent, meaning there's at least an x squared in every term, which would leave us with x cubed minus 1. So going back to our original problem, we look and we have exponents of 5/3 and 2/3. 2/3 is the smaller, so we're going to factor out a 3z plus 2 all to the 2/3. That leaves a 3z plus 2 to the 3/3 minus 1. 3z plus 2 to the 3/3 is the same as 3z plus 2 to the 1, which is in fact just 3z plus 2. We can now simplify, and we get 3z plus 2 minus 1, which is just 3z plus 1. There's our final answer. Again, if you want to, you should be able to multiply through. It's a little trickier just because you would have to initially separate out this positive 2 and minus 1, but the two equations are equivalent. So our final answer is the factored form of the polynomial we started with. Again, if you have any questions on factoring, if you want more practice problems, please look at the problems in our text. They're a great resource, or use the online problems through the Hawk software.